Hi everyone. Today we'll be looking at the paper 2, Pure Mathematics 2 of June 19. So question 1, we're being given that 2 to the x times 4 to the y is 1 over 2 root 2. And we need to express y as a function of x. So we need to express everything as powers of 2. So 4 is just 2 squared. And this is 1 over 2 times 2 to the half. So 2 to the x times 2 to the 2y is 1 over 2 to the 3 over 2, which means that 2 to the x plus 2y, because if I've got the multiplication with a common base, I'm adding up the indices, is equal to 2 to the minus 3 over 2. So I can equate the powers now to get that x plus 2y is minus 3 over 2. We are not done. We need to make y the subject. So y is minus 3 over 2 minus x and all over 2. We haven't been told to give the answer here in a particular form, so we can just stop at this point here. Question 2 is the speed of a small jet aircraft measured every 5 seconds, starting from the time it turned onto runway until the time it left the ground. We've got the result here, time and speed. And using all of this information, we need to estimate the length of runway used by the jet to take off. So this is a very clever way of asking us to give here an answer using trapezium rule. Why? Because in a speed-time graph, we know that it's the area under the graph that's giving us the distance covered. So this is essentially the classic table that we would get and use when we apply the trapezium rule. So we're just going to see that the length will approximately be a half. Now the height of the trapezia is simply the difference between two x values, which is t in our case, so 5. And then we've got the first and last y values once and all the intermediate values twice. 2 plus 42 plus 2 times 5 plus 10 plus 18 plus 28. We need to be extra careful here with the brackets in order not to mess up the expression we input on the calculator, and this will give us a result of 415 meters. In B, we are told that the jet accelerated smoothly in these 25 seconds, and we need to explain whether the answer we got is an underestimate or an overestimate of the length of runway used by the jet to take off. So we've got smooth acceleration, it says here. So it means that it's increasing, it's picking up speed all the time. So if I was to roughly draw the diagram here, the speed time graph, just to get an idea of what's happening for that one mark, we've got intervals from 0 up to 25 every 5. And we see that we've got a maximum of 42, but the intervals here progressively become larger and larger, which means that it probably looks something like this. So we see that the curve is bending inwards so that all of the trapezia drawn lie above it. So all of the trapezia will be lying above the line here, the curve. So we will be looking at an overestimate. So we can just say that it's an overestimate since the curve bends inwards. Now, this is not an easy question. You need to consider on exactly what's happening here in order to understand that it's essentially a hidden trapezium rule here. In 3, we're given a sector here, and we know that the radius is 5 and the angle is 40 degrees. And we have an attempt here by someone to find the area of the sector shown. And this is what they do, a half r squared theta, and they do a half times 5 squared times 40, which is 500. And explain the error made by the student. Well, we know that this is true if and only if theta is measured in radians and the angle is in degrees. The student has worked in degrees, so that's the mistake here. So what we need to do here is simply say that student should have worked in radians. For 1 mark. And then in B, we need to write out the correct solution. Well, we first need to convert the 40 degrees into radians. So we know that 40 degrees is 40 out of 180 pi radians, which simplifies to 2 pi over 9. And therefore we have that the area will be a half times 5 squared times 2 pi over 9, and this is giving me 25 pi over 9 squared centimeters. In question 4, we are being told that we've got this curve C1, which is defined parametrically in terms of t, and C2 is just a circle centered at the origin, radius root 66, and we need to find the coordinates of S, the point in the 4th quadrant where the two curves meet. We see that there is symmetry here, and there are actually 4 points of intersection, 1 in each quadrant. In order to find this point S, we need to solve simultaneously the two parametrics together, the Cartesian. It makes sense to take the parametrics and substitute them into the Cartesian. This will give me 10 cos t all squared plus 4 root 2 sine t squared equals 66. So we have 100 cos squared t plus 32 sine squared t being 66. We need to solve this, so what we will do is actually convert everything into cos. That will be one option. So 100 cos squared t plus 32 times 1 minus cos squared t is 66, leading to 68 cos squared t is 34, or simply that cos squared t is a half, which means that cos t could be plus minus 1 over root 2. Now I know we are tempted at the moment in finding t, but if we just pay attention here, we know that the x coordinate of S is positive, but the y coordinate is negative. So I'm just gonna use the fact that cos t is 1 over root 2, the positive part, and say that x, which is 10 cos t, it's just 10 times 1 over root 2. And for y, which is 4 root 2 sine t, I'm just gonna find sine t. So what we can do is draw a right angle triangle here, and if cos t is 1 over root 2, then sine t is also 1 over root 2. Actually, we know from the graph again that y should assume a negative value, so I'm just going to use minus 1 over root 2. So this would be 4 root 2 times minus 1 over root 2, which leads to minus 4, and therefore S should be having coordinates of 5 root 2 comma minus 4 if I use the calculator to plug in the values here. So that was using the Cartesian together with the parametric equations and actually substituting the parametrics into the Cartesian. An alternative would have been first concentrating on the parametric equations and seeing whether we can get a Cartesian out of this. So that x is 10 cos t and y is 4 root 2 sine t. And we know that sine squared t plus cos squared t must be 1 for all values of t. So we have that y over 4 root 2 squared plus x over 10 squared is 1. This leads to y squared over 32 plus x squared over 100 is 1. And we could make one of y squared or x squared the subject and substitute, or we could just refer to the other Cartesian equation of the circle. X squared plus y squared is 66, and simply say that y squared is 66 minus x squared. So if we substitute into this one here, we should be getting that 66 minus x squared over 32 plus x squared over 100 is 1. So we need to find the LCM of this here, or we just multiply the first one by 100, the second one by 32, and the one by 3200. So 6600 minus 100x squared plus 32x squared is 3200. And this is leading to 3400 is equal to 68x squared. So 3400 over 68. And I take the square root of that, knowing that I'm looking for the positive square root here, so no need to worry about the plus and the minus. So I'm just gonna do the root of 3400 over 68, which is 5 root 2. And then to get the y, I'm just gonna substitute, say, here. So y squared is 66 minus 5 root 2 squared, which turns out to be 16. So y is plus minus 4, and I take the negative because I know from the given graph that I'm looking for the negative y value. So this is still leading to the same answer, 5 root 2 comma minus 4. Now question 5, again we're given a diagram here, and we have a sketch of the equation y is root x, and we have x, y, a general point on the curve, and the rectangle shown shaded here. And we need to calculate the limit as delta x goes to 0 of the summation from x is 4 up to 9 of root x delta x. Now, if you pay attention, root x is the height and delta x is the width of this rectangle here. And as delta x becomes progressively smaller, we are approximating a series of rectangles of decreasing width that cover all of this. So in other words, we've been asked to calculate the area here. This is really checking whether you're aware that the integration is a process of infinite summation. So all we have to do here for 3 marks is just integrate from 4 to 9 x to the half dx. So we increase the power by 1, divide by the new power, and the limits are 4 and 9. So that's going to be 2 times 9 to the 3 over 2 over 3, minus 2 times 4 to the 3 over 2 over 3. And if you plug this on the calculator, you get an answer of 38 over 3. Question 6. We've got g of x defined for x less than or equal to 2 in terms of a quadratic, and it appears as a straight line for x greater than 2. We need to find the value of g of 0. So let's start with that one. Now g of 0, let's start with g of 0. I will go for the first part here, which is 0 minus 2 squared plus 1, which gives me a result of 5. 2 squared plus 1 is 5. So I'm looking for g of 5. And now if the input is 5, it means that it's the second branch that actually goes alive. So it's going to be 4 times 5 minus 7, which is 13. So that's part A. And then we need to find all values of x for which g of x is greater than 28. So if we just revisit for a moment here, we've got the line of y is 28, and we actually need to find these two values here. It's actually quite helpful that we have the diagram here, because these will be the two critical values we are after. So we will start off with x minus 2 squared plus 1 being 28. So x minus 2 squared is 27. X minus 2 is plus minus the root of 27. And we get x to be 2 plus minus root 27. Now if we just revisit for a moment the graph, we see that we want the negative value. We want the value that's less than 2, because the second value we get, it's actually if this continues on as a normal parabola. However, it's a truncated parabola which only works for x less than or equal to 2. So the value here is gonna be the 2 minus root 27. That's the value we get here. And for the other part, we need to set 4x minus 7 is 28. 4x is 35, leading to x being 35 over 4. Remember, we need to find the values for which g of x is greater than 28. So it has to be this part here and this part here. So anything less than 2 minus root 27 or anything greater than 35 over 4. Both of them are strict inequalities because the given inequality we started off with was also strict. Now moving on, the function h is defined like this. Explain why h has an inverse but g does not. Now this one here is only the first branch, so it's only this part here, and you can see that it is 1-to-1. It is a 1-to-1 function. However, the g of x we were given here is not a 1-to-1 function because it fails on passing the horizontal line test, which means we've got horizontal lines that cut in more than one place. So all we have to do here is simply say that h of x is a 1-to-1 function but g of x is a many-to-one function. So as it is many-to-one, if we try to invert it, we'll get something that it's 1-to-many, which does not qualify for a function. It is just a mapping. And then D, we need to solve h inverse of x is minus a half. The first thing that someone might try doing here is actually finding h inverse. However, it's only 3 marks here. We need to solve h inverse of x is minus a half. So instead of actually finding h inverse, I'm just gonna do age of both sides. So x will be age of minus a half. So I'm just gonna say that I will plug in the value of minus a half in the place of x. And I will simply get an answer of 7.25, or if I want to put in exact form, it's gonna be 29/4. Certainly makes my life a lot easier if I just notice that I don't really need to find the inverse of age, but just work on age itself. Question 7, we've got a factory that's making bars of soap. The total cost in Y pounds for making X bars of soap is depending on a fixed cost and a proportional cost. And we need to write down the general equation for Y in terms of X. So this is simply a linear relationship of the form Y is KX plus C, where C is the fixed cost, which is irrespective of the number of bars of soap produced, and K is the proportional cost, which depends on the number of bars of soap produced. We're then told that the bars are sold for £2 each, and we have a day where 800 bars are made and sold, and we make a profit of 500, and on a different day 300 bars of soap are made and sold, and the factory is making a loss of £80. Now notice that this is the profit, which is the difference between the sales and the cost. So if we produced and sold 800 bars of soap, it means we had an income of 1600, 800 times 2. And for us to be making a profit of 500, this means that when Y is 1100, X is 800. So we had an income of 1600. For us to be making a profit of 500, it means that we had a total cost of £1,100. Whereas for the second piece of information, for 300 bars, the income is 600. And for us to be making a loss of 80, it means that the Y was 680 and X is 300. So this will essentially lead to a system of simultaneous linear equations. I'm just substituting here, and the unknowns are K and C. So this is what we have here, and what we can do is actually deduct one from the other. So if we do 1100 minus 680, we are getting a result of 420 is equal to 500K, which leads to K being 0.84, which agrees with the printed answer. And I'm just gonna substitute back into one of the two equations the value of K 0.84, and this will give me C is 428. Therefore Y is 0.84x plus 428 as required. Now, with reference to the model, interpret the significance of the value of 0.84 in the equation. This is just the coefficient of x, which means that for every extra bar of soap produced, we've got the total cost. The total cost increases by 0.84 pounds. And then for part D, assuming that each bar of soap is sold on the day it is made, what is the least number of bars of soap that must be made on any given day for the factory to make a profit that day? Now we know that the income is simply 2x, where x is the number of bars of soap produced, and we want a profit. They are asking for a profit, so we want the income to be greater than the cost. Profit means that 2x is greater than y. So I'm just gonna say 2x is greater than the expression we found for y, 0.84x plus 428. And then we can simplify this by saying 2x minus 0.84x, which is 1.16x greater than 428. So dividing 428 by 1.16 gives a value of 368.97. Therefore, at least 369 bars of soap needed. So a simple inequality to be solved in order to determine the minimum number for a profit to be generated here. In 8, we're looking at two independent parts, I and II, involving the sigma notation. Whenever we see a sigma notation, maybe it's worth considering the first few terms. We start here at 4, we see an infinity. I'm thinking of sum to infinity, probably the sum to infinity of a geometric progression. So the sum of 20 times a half to the r, from r is 4 up to infinity, is simply 20 times a half to the 4 plus 20 times a half to the 5 plus dot dot dot. We see that the first term is simply 5 over 4. So this is sum to infinity of a geometric progression. And the first term is 20 times a half to the 4, which is 5 over 4, and common ratio a half. So this is just a over 1 minus r, which gives a result of 5 over 2. In II, we need to show that the summation of log of n plus 2 over n plus 1 from 1 up to 48 is 2. Well, we're seeing logarithms here, so maybe it's worth splitting this down into the summation from n is 1 up to 48 of log of n plus 2 base 5 minus log of n plus 1 base 5. We could plug in a few numbers here just to see what's happening. It's gonna be log of 3 base 5 minus log of 2 base 5 plus log of 4 base 5 minus log of 3 base 5 plus log of 5 base 5 minus log of 4 base 5. And I start seeing a pattern. It's a telescopic sum where consecutive terms simplify out. So if this continues, then the last term here would be log of 50 base 5 minus log of 49 base 5. We've got all cancelling out apart from the one on the top left corner and one at the bottom, top right corner and then bottom left corner, which is log of 50 base 5 minus log of 2 base 5, which is log of 25 base 5, which is simply 2. So this is what we get here. An alternative, I guess, would be to start off by saying the sum from 1 up to 48 of log of n plus 2 over n plus 1 base 5. I could start off by just writing the first few terms. So it's going to be log of 3 over 2 base 5 plus log of 4 over 3 base 5 plus log of 5 over 4 base 5 up to log of 50 over 49 base 5, and the sum of the logarithms is the logarithm of the product, so this is going to be log base 5 of 3 over 2 times 4 over 3 times 5 over 4 times dot 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 times 50 over 49. Again, we see the simplifications here, so we're just left with log of 50 over 5 over 2, sorry, base 5, which is log of 25 base 5, log of 5 to the power of 2 base 5, which is 2 log 5 base 5, which is 2. So two different ways of showing that this is the case, and this is exactly what we get. In question 9, we've got a research engineer testing the effectiveness of the braking system of a car when it's being driven in wet conditions. So the engineer has measured and recorded the braking distance d meters when brakes are applied from a speed of v kilometers per hour, and we've got graphs of d against v and log d base 10 against log v base 10 plotted, and we've got a data point from each graph. And explain, it says, how figure 6 would lead to the engineer believing that the braking distance may be modeled by the formula d is kv to the power of n, where k and n are constants. So if I just look at this graph here, it's a straight line. We've got log v being the independent variable and log d being the dependent variable. So log d is assuming the role of y and log v in the role of x. So this is log d base 10 is m log v base 10 plus c. So I could say that log of d base 10 is log of v to the m base 10 plus c. Log d base 10 minus log v to the m base 10 is c, which means that log of d over v to the m base 10 is c, and this leads to d over v to the m is 10 to the c, which simplifies to d being 10 to the c v to the m. So if we just compare with the given expression here, we can see that their k is our 10 to the c, and their m, our m, sorry, is their n, and we can therefore conclude that d is kv to the n. We also need to show that k is approximately 0.017, and this is exactly where we can make use of the points here. We know that we pass through 0 minus 1.77, and we also know that we pass through 3020. So from this 0 minus 1.77, we can safely conclude that this is the y-intercept. So our c is minus 1.77, and k is 10 to the minus 1.77, which our calculator gives us 0.017 0.01698, which is 0.017 as required. And then now that we've got the value of k, we have to find a complete equation for the model giving the value of n to 3SF. Notice that I will be using k to be 0.017 and not the 0.01698 we just got. From the first graph, we know that when v is 30, d is 20. So v is 30, d is 20. I'm just gonna substitute here to get 20 is 0.017 times 30 to the n. So 20 over 0.017 is 30 to the n. So log of 20 over 0.017 is n log 30, which means that n must be log of 20 over 0.017 over log 30. We're just gonna put this on the calculator and hopefully get the right answer here. So divide that by log of 30. We got an answer of 2.07876, which to 3SF is just 2.08. So in part B, we have to give the complete equation. So I just have to say that D is 0.017, V to the 2.08. So this is what we get here for part B. And then C, we've got someone driving at 60 kilometers per hour in wet conditions when he notices a large puddle in the road 100 meters ahead. It takes him 0.8 seconds to react before applying the brakes. Use your formula to find if they will be able to stop before reaching the puddle. So we first need to realize that during those 0.8 seconds, the car is still traveling at a speed of 60 kilometers per hour. And we then need to calculate the distance needed to stop. So we will start off by actually doing the second. So when V is 60, we see that D is 0.017 times 60 to the 2.08. So let's start by doing that. This is giving a result of 84.92 meters. That's the braking distance, but we also need to find the distance covered during those 0.8 seconds. We know that the car was traveling at 60 kilometers in an hour, which is 3,600 seconds. So we know that this is 60,000 meters in 3,600 seconds. So we're just gonna calculate how many meters in 0.8 seconds. And we get that X is 60,000 times 0.8 over 3,600. So this is giving a result of 13.33 meters. And we can say that 84.92 plus 13.33 is equal to 98.25, which is less than 100 meters, and therefore the car will stop in time. So that was part C of this question. Question 10 is a question on vectors. We've got a triangle OAB, it's a sketch, it's not accurately drawn. OC is 2 times OA, which means that if I extend the line OA and I go twice the distance, that will be C here. So A is the midpoint. And the straight line through C and M is the midpoint of AB. So M is somewhere here, say. And this straight line here is cutting through the OB at N. So this is N. And we need to find CM in terms of A and B for 2 marks. Now, we want to go from C to M. M is the midpoint of AB. So from C to M, it's only 2 marks, so it should be something straightforward. Someone could go from C to A and then from A to M. So it's CA and then AM. Now to go from C to A, it's just negative A because I'm going against the direction of OA. And to go from A to M, it's just the half of AB. So this is negative A plus a half AB. Now to go from A to B, we simply do B minus A. And all of this is giving me a result of a half B minus 3 over 2A. So that's the expression for CM. And we then need to show that ON is given by this expression here in terms of A and B and lambda, a scalar constant. So I want to go from O to N. So someone could actually go from O to C and then from C to N. So in B, ON is OC plus CN. Now going from O to C, it's just 2A. But going from C to N is the same as going from C to M, just a part of that distance. So actually that part will be greater than 1 because it's extended to go from C to M and then to N. So I'm just gonna say plus lambda CM. So this is 2A plus lambda times the answer to part A of this question, which if I expand and collect the A terms together, I get 2 minus 3 over 2 lambda A plus a half lambda B, which is exactly what I was asked to show, so as required here. Hence it says, part C, prove that ON to NB is 2 to 1. So the ratio of ON to NB is 2 to 1. Now, we have found one expression for ON, but we know that ON is also mu times OB, where mu is another scalar. So ON is mu times OB. So it's mu B. And I'm just gonna equate the two expressions that represent the same vector. So this is equal to 2 minus 3 over 2 lambda A plus a half lambda B. And then I will be equating A and B terms. So this is the B term on the left and this is the B term on the right. So we know that mu is a half lambda. And if I just look at the A terms, there is no A term on the left, but there is this A term on the right. So I'm just gonna say 0 is 2 minus 3 over 2 lambda, which means that 2 is 3 over 2 lambda, leading to 4 over 3 being lambda. I will back substitute into mu, and I'll get a half times 4 over 3, which is 2 over 3. So going from O to N is the same as going from O to B 2/3 of the way, 2/3 of the way. So this means that this is 2 and all of this is 3. So that must be 1. So this means that we are splitting ON to NB in the ratio of 2 to 1. So we need the conclusion here. Hence, ON to NB is 2 to 1 as required. Next question 11, we've got the graph of x to the x, and by first taking logarithms, we need to find the x-coordinate of the turning point of C. So just gonna follow what we've been advised to do here. So we've got y is x to the x. So I'm just gonna take ln of y is x ln x, and then use implicit differentiation. So 1 over y dy dx is equal to the product rule. Differentiate the first one, keep the second, ln x, plus keep the first, differentiate the second. So 1 over y dy dx is equal to ln x plus 1, which means that dy dx is y brackets ln x plus 1. For a turning point, we want this to be 0, and therefore we want ln x plus 1 to be 0. Ln x is minus 1, so x is e to the minus 1. So we need to find just the x coordinates, so we are covered for 5 marks for part A. Now, there's also the solution of y being 0, but if you look at the definition of x to the x, it's not defined for x being 0, so that's not a turning point. Now the point PA2 lies on C. We need to show that A lies between 1.5 and 1.6. So what we are actually being told here is that when x is when x is alpha, y is 2. So when x is alpha, y is 2. So we've got that 2 is alpha to the alpha. I'm just gonna make this 0. So 0 is alpha to the alpha minus 2. And I will let f of x be x to the x minus 2. I will calculate f of 1.5 and f of 1.6, and I'm really hoping for a change of sign here in order to conclude the root. So for 1.5 to the 1.5 minus 2, I got minus 0.163, and for 1.6 to the 1.6, I got 0.121. So we say change of sign, and f of x continues. Hence, alpha is between 1.5 and 1.6. So that was the part B of this question. And then a possible iteration formula that can be used is this one here. We have to use this formula with x1 being 1.5 to find x4 to 3 dps. So we're just gonna use the calculator here. We have x1 is 1.5. So x1 is 1.5. x2, I'm using the iteration formula here, it's 2xn to the 1 minus xn. So it's 2 times 1.5 to the 1 minus 1.5. So what I'm doing here, I'm putting 1.5 and pressing the equal sign on the calculator. I've just stored this on the calculator, and I do 2 uns to the 1 minus uns. So each time I press the equal sign, I'm moving an iteration down the road. So this is 1.633. Then x3 is 1.466 and x4 is 1.673. I need to follow the accuracy instructed here, so I go for 3 decimal places. The answer is 1.673. Now, D, describe the long-term behavior of xn. So we really need to look at the values here. We started at 1.5, we went up to 1.633, then down to 1.466, then 1.673. So the first thing we notice is that we've got oscillations, because it goes up and down, and it's oscillating or fluctuating between 1 and 2. So what the examiner is expecting here is to say oscillates between 1 and 2. This part of the question is worth 2 marks, and 1 mark is given for the word oscillation, or it fluctuates, or it goes up and down, or it alternates. And the second mark, if we say between 1 and 2. If we say between 1 and 2, so we go up and down. So we could press the equal sign on the calculator, and we will be seeing that it goes after a few presses of the equal sign, it will be going into 1, 2, 1, 2, 1, 2. So it's worth experimenting on the calculator to see that it goes to 1 and 2. So that was this the last part of this question. Question 12. We need to prove that cos 3 theta over sine theta plus sine 3 theta over cos theta is equivalent to 2 cot 2 theta. I think I will certainly start on the left hand side, as that is more things we could do on the left hand side here. I'm a bit puzzled by the 3 theta and the theta on the left, and then the 2 theta on the right. So the first thing I will do is certainly attempt putting everything under the same denominator. So the denominator will be sine theta cos theta, and I'm getting cos 3 theta cos theta plus sine 3 theta sine theta. It doesn't take long to realize that in the numerator we've got the addition formula for cos A minus B, with A being 3 theta and B being theta. So that's a really good sign, because this is where we get the 2 theta from. And then I couldn't help notice that in the denominator I've got a structure that mimics the double angle for sine. We are just short of a 2. So if I put a 2 here and a 2 here, it means I have intelligently multiplied by 1, and then in the numerator I'm having an extra 2, in the denominator I'm having sine 2 theta, which is 2 cot 2 theta, which is the right hand side as required. And then B, hence solve. I have to say something about the word hence here. When the question says hence, it means you have to use what you've been founding in the previous part. So we know that this part here is just 2 cot 2 theta is equal to 4 from 90 to 180. So 2 cot 2 theta is 4. So cot 2 theta is 2, which means that tan 2 theta is a half. I will generate my PV. So the PV is 26.56505. So 2 theta is 180 n plus the PV. I will divide everything by 2 in order to solve for theta. So 13.283. They are expecting answers between 90 and 180 to 1 dp. So I need to put n is 1 here, and I will be getting a result of 103.3 degrees, and that's actually the only solution we could get in the range of 90 to 180. Question 13 now. We're being given a storage tank. It's modeled in the shape of a hollow circular cylinder closed at one end as shown. The walls have negligible thickness. The radius is r, the height is h, the volume is 6 cubic meters. And we need to show that the surface area of the tank is given by the expression here. Now, the surface area is simply going to be consisting of the base here, pi r squared, the curved surface area of a cylinder, which is 2 pi r h, and then the area of the hemisphere, which is a half of 4 pi r squared. So we could start by that. So the area is the base, pi r squared, the curved surface area, 2 pi r h, and then a half of 4 pi r squared. So this is simplifying to 3 pi r squared plus 2 pi r h. Now this is an expression that involves h. We need to use the fact that the volume is fixed at 6 cubic meters in order to find the relationship between r and h. So we know that the volume is pi r squared h, it's the volume of the cylinder, plus a half of 4 over 3 pi r cubed. 4 over 3 pi r cubed is the volume of a sphere. Let's divide that by 2 to get the volume of a hemisphere. The volume is 6, so this is pi r squared h plus 2 over 3 pi r cubed. I will multiply everything by 3 to get 18 is 3 pi r squared h plus 2 pi r cubed. So 18 minus 2 pi r cubed over 3 pi r is simply rh. The reason I made rh the subject here is because I can simplify all of these with rh. So the area will be 3 pi r squared plus 2 pi times 18 minus 2 pi r cubed over 3 pi r. So we see that the pi will cancel out, and I will then expand. I will be getting 3 pi r squared plus, now 2 times 18, 36 over 3, it's 12 over r, minus 4 pi r squared over 3. So this is giving a result of 12 over r plus 5 over 3 pi r squared, which is exactly what we had to show here. So as required. We're trying then to minimize the surface area, and we need to use calculus to find the radius for which the surface area is a minimum, and then calculate the minimum surface area, giving our answer to the nearest integer. So in B, I'm just gonna do dA by dr. We have 12 to the r minus 1, so it's gonna be the derivative minus 12r to the minus 2 plus 10 over 3 pi r, and we want that to be equal to 0. So we want 10 pi r over 3 to be equal to 12 over r squared, which leads to 10 pi r cubed is 36, or simply that r cubed is 36 over 10 pi. So I will take the third root of that. This is the only turning point. So the root of 36 divided by 10 pi. The answer is 1.07. So this 1.07, we just had to find here the radius of the tongue, for which this is a minimum. So this is what we get here, and then we can proceed in finding the actual minimum area. So the minimum area is when that exact value is used. So it's gonna be 12 over 1.07 ... I'm using full accuracy, plus 5 over 3 pi r squared. So I'm maintaining full accuracy to avoid wasting any marks due to premature rounding, and hopefully everything should work out here to give the desired result. We get a 17.21. This is squared meters. They want an answer correct to the nearest integer, so it's gonna be 17 square meters. So this is what we get here. If you look at the official mark scheme that I have in front of me as well, it gives here the number 1.05. Well, what I'm getting on the calculator is 1.07, and so you should consider there is a small error in the mark scheme. Question 14, we start off with a substitution here. U is 4 minus root h. So to show that this integral here is this word case a constant, so let's start with the substitution. U is 4 minus root h. Actually, before I do anything, before I start differentiating, I'm just gonna say that root h is 4 minus u, and therefore h is 4 minus u squared, which means that dh is minus 2 4 minus u du. Now, the integral of dh over 4 minus root h will simply be the 4 minus root h giving its place to a u, and dh being minus 2 4 minus u du, which is simply minus 8 over u plus 2u over u du. The u's will cancel out, and I'm left with minus 8 ln u plus 2u plus c. I'm gonna put 4 minus root h in the place of u, so it's minus 8 ln of 4 minus root h plus 2 brackets 4 minus root h plus c, which is minus 8 ln 4 minus root h minus 2 root h plus 8 plus c. Now 8 and a constant is just another constant, which we will call k to match the printed answer. So this is minus 8 ln of 4 minus root h minus 2 root h plus k. So this is what we get here as required. And then moving on to B, a team of scientists is studying a species of slow-growing tree. The height is modeled through this differential equation, and t is the time measured in years after the tree has been planted. And find, according to the model, the range in heights of trees in this species. So we can just look at the differential equation here, the range in heights. So we know that the height is increasing. It's a slow growing tree. It's only growing though. So because t is always positive and we want the derivative to be positive, we want 4 minus root h to be positive. So 4 minus root h to be positive. So 4 is greater than root h. So 16 greater than h. So we can simply say that the height varies between 0 and 16. So 0, h, 16. If you want to include the 0 or the 16, that's okay. They are accepting anything. They are accepting both strict and relaxed inequalities here. And then one of these trees is a meter high when it's first planted. And according to the model, calculate the time this tree would take to reach a height of 12 meters, giving answers to 3 SF. So we really need to solve the differential equation. This is where the fact that we have worked on the integral a bit in part A will come in handy. And we also have got some boundary conditions. It's a meter high when it is first planted. Let me start off by writing here the differential equation. So we have that dh dt is t to the 0.25 4 minus root h over 20. We will separate the variables, which means we will collect the h terms with the h on one side and the t terms with the t on the other. So this is what we get here. And then we just integrate both sides. We have the integral of 1 over 4 minus root h, which is minus 8 ln 4 minus root h minus 2 root h. I'm going to drop the constants, only going to appear on the right hand side. And this is t to the 5 over 4 over 5 over 4, and we've got the 20 as well, plus c. And we know that when t is 0, h is 1, and this will help me find the unknown c. So minus 8 ln 4 minus root 1 minus 2 root 1 is 0 plus c. So minus 8 ln 3 minus 2 is c. So this leads to the relationship minus 8 ln 4 minus root h minus 2 root h is, now we've got some simplifications. The 4 with the 20 leaves me with the 5. So it's t to the 5 over 4 over 25 minus 8 ln 3 minus 2. And we need to find the time to reach a height of 12 meters. So just gonna put h is 12. So I've got minus 8 ln 4 minus root 12 minus 2 root 12 is t to the 5 over 4 over 25 minus 8 ln 3 minus 2. I'm just gonna plug everything on my calculator here to see what we can get. And we have to be careful when we plug this in. We don't want to make any numerical mistakes. And we get that the t to the 5 over 4 is equal to 221.2795. I'm just gonna raise this to the power of 4 over 5. So if we just do this, we will be getting a result of 75.15. So this is 75.2 years. So that's the time for the height to reach a height of 12 meters.